Number 14, let's go. Alrighty, so I don't fully know what I'm gonna do today. I've got a bunch of ideas, a bunch of things that need to get done. I haven't yet decided what's gonna happen first. So come along with me, we'll figure it out. Definitely, I need to look into those threads that I royally borked at the end of the last video. Spent a couple days at home with the fam. Awesome time. Got a quarantine haircut by my wife. Did a killer job. So yeah, let's figure it out. I have an idea. My editor, Fraser, is at home, bored right now. Let's give him a, Fraser, I want a 16-second epic B-roll sequence. I'm gonna film a bunch of random garbage and throw it together to make it look cool. Okay, well, one thing I have to do, for show, is very carefully measure this probe so that I have the model of it in Fusion. Now, I haven't actually been to the Bloom website yet to see if I can download the solid model. I will do that right now. But yeah, in order for in order to do probing within Fusion and then also to do probing within Camp Lead or to have it all work, I need to model this up. So let's do that. Time lapse. I'm going to do a little screen cap. A few minutes of that, you can speed that up real fast. All right. I have this thing modeled up in Fusion now. Sweet. Fairly simple, I mean, not the most accurate modeling technique, just using calipers, measuring diameter, length, etc., etc. This is how I kind of started designing parts, and I recommend to everybody who wants to get into it too. Buy some calipers. These are Mitutoyo ones. They're $150 to $220, depending on the coolant proof ones or not. But you can get cheap ones from Harbor Freight or Amazon or whatever for like 20 bucks. They're fine. I used them for years. Excellent beginner set. Anyway, they're great. You can just go in and you can gently measure diameters and diameter and length, and it gets you any round object basically. And I would measure everything. Just all the stuff around my desk. I'd try to model this. I would try to model all kinds of stuff and then get more and more complicated. So having a set of these will let you bring a thing into existence, and that's going to teach you the process of modeling it, not necessarily designing it. Because when I stare at a blank slate and I'm like, okay, let's design a knife, it's hard. So design something you know, design something you can feel and measure. Good tip. I was going to say though, oh yeah, so on the control, when it laser measures this thing, or not with the laser, but when it does the routine to measure the length of this thing, it measures from the face right there to the tip of the tool. I compared that with what I measured in this, and there's about 11 thousandths of an inch difference, which, to give you a perspective, 11, right, is that much. 2 hairs beside each other, maybe 3. So my measuring technique over a 5-inch distance was 11th thou off. I'm pretty happy with that. I'm going to tweak the model to match what the computer says, and then we're dialed. All right. In the last video, I screwed up the threads that will hold this Tombstone onto the pallet. I'm not very happy about that, but what I'm doing right now is I'm rerunning the correct thread pitch to, I was able to do 1 instead of all 4. And I just open it up a little bit with the correct thread pitch, and I can thread a bolt in there really nicely. The thread strength is going to be garbage, it's going to be weak, so I don't know yet. The other option is to go from an M8 to an M10 It gets a little tight clearance-wise to make that fit. I also have some 5/16 by 18 threads, which were very close, but I decided to go to the M8 instead. Anyway, kind of playing with that right now. It might work fine. This is a test palette. This is an experiment anyway. I've got more mistakes to make on it, hopefully not, but I've got certainly more things to learn on it, so maybe I should just go through the process and finish this one and establish the process so that when I make the next one, the right one, it's good. So that's kind of the back and forth that I'm going in my brain right now, trying to figure out what exactly I should be doing. I was this close to just taking this guy. Oh goodness, 55 pounds. Taking this guy and just starting over again. I don't want to do that yet. It's pretty heavy. But anyway. Ooh, that fits nice. A little tiny bit tight at the bottom, but it goes in with almost, very, very little effort. So it's not cross-threading or anything, which is a good thing, but like I said, there's no wiggle either, which is nice. Like I said, thread engagement, thread strength is not gonna be awesome. Another sweet thing about 5-axis machines is you can drip dry. You can tilt it and let all the coolant fall out. Some people even spin it around or turn it upside down as much as they can and let all the coolant drain out. It's pretty cool. Okay, I've decided. I'm gonna forget the M8 with bad thread idea and I'm gonna go up to an M10. I did some clearances. It'll just fit with other features and cross holes and stuff. It'll work, it'll be strong, I'll be able to save this palette, it'll be better, it'll be great. So that's what I'm doing. Alrighty, let's give this a little test fit. I don't actually have a M10 thread gauge, but let's see how we did. I won't be surprised if they're a little tight. A tiny bit tight, but I can do that by hand. That's pretty cool. So now I just have to make the choice. Do I run it again or do I leave it? It's great actually. Yeah, that goes in just fine. Cool, man. Okay, so we have so far fixed this. Now we have 4 bigger holes that are threaded for M10. They work, which means the next step is to get this off of that and onto its own pallet. So I still got some gas in the tank here. Maybe we'll do a pallet change. We can learn about that, and then we'll mill the holes in the pallet. All right, so now that all that side is done, I can pull it off the vise and then do a pallet change. The robot is alive. It's homing itself right now. Now it's gonna home at the upper end. All right. Got this thing powered up. I think it's ready to go. Alright guys, let's get this robot cracking. I'll show you how this works. So I turned it on, I homed it, I got it all set up. Let's go ahead and call pallet number 9. It's going to put the vise back in pallet number 8. I can tell because it says pallet 5-axis 8. So it's a simple, which one is it? This one, cycle def 340. Simple cycle, I just go over, I type I want pallet 9, and cycle start, let's call that. Cycle start, here we go. Pallet orients, the tool goes out of the way, door opens up. Hello, Mr. Roboto. It's pneumatic grippers in there. Grips the pallet, lifts it up. There's air that comes up here. Okay, it comes back. Rotates, puts it forward, drops it, releases, rotates, comes to grab this guy, lifts it up, yes. Slowly comes down. Now there's air blasts that go under the pads to keep everything nice and clean. There's an O-ring around the outside, and then the robot goes home. Goodbye. And then the pallet orients to C0. And then we're ready to rock. So I've been playing with this Bloom touch probe right now. It's got a teeny tiny little ruby ball at the end. And for those of you who don't know what this does, it's a sensor inside that measures when the stylus moves up or sideways in any direction. So it can measure a hole for position and for size, and it can measure a Z surface and do all kinds of cool stuff. So I am simply probing Z minus, cycle start. Now, I had this pallet in a few minutes ago. I changed it out, I put the vise back in, I came back, and I went to roughly the same position, not exactly the same position. And then let's cycle start here. I don't even know if you'll be able to see it move because I don't have it moving very far. Done. That is how far off it is from before. That's 5 zeros and then a 9. That's absolutely bonkers nothing. Nothing, nothing, nothing. If that was, okay, cancel that, cancel that. If this digit was a 1, I'd be fairly impressed. But that's a 0, and that's a 0, and that's a 9. I was also doing repeatability testing where I would probe, and then 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 probe. Same spot. Let's see, I got a couple graphs here. This one is my same spot probing, but the numbers are all bonkers. They're all 5 digits, and then a 3, and then a -2, and then a -5, and then a -7. So the range is still, what was it, 4 to 7? So the range is still 4 zeros and then a 1, 1. And then I was probing across the entire face of the pallet, and I got about 2 ten-thousandths difference. So see how this one is maximum of 3 digits and then a 2. That's 2 tenths. I can measure that with some of my other tools, my hand tools, like this guy. But that is kind of dish in the pallet of 2 tenths, which is, it's fine. It's not a huge deal. But I was measuring there and then out, 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 and then I also measured in a whole bunch of different spots around the pallet just to see how flat it is. This is the one that a couple episodes ago we stoned, and you can see the concentric rings, but even with those, it's darn flat. So the question I've been wondering to myself for months now is, I know the machine is repeatable. I have really good confidence that the pallet changer and the Aroa base and mounting system is very repeatable. I want to know how repeatable are the thickness of the 25 pallets that I have. I've tested now 2 of them back to back, and they're well under 1/10,000th of repeatability in Z thickness in roughly the same spot. So I'm going to go through and I'm going to measure a couple. I figure worst case, I could go in with a really nice tool, and face every single one down, do a pallet change, face the next one down, do a pallet change, face the next one down, get them all exactly the same to give me a basis starting point for everything. I haven't decided if I'm going to do that yet. I'm leaning towards no right now, but as I do a little bit more testing, we'll find the answer to that. Because yeah, the more consistent everything is at ground zero today, before I get deep into it and start throwing stuff on all the pallets, I think the happier I'll be later on. But we'll see. They might be fine. And maybe I'm overdoing this, but full Grimsmo. You know, it's what I do. Ta-da! It's really trippy watching the robot like point right at you. So I'm playing with the idea of facing down the pallets, and then I did a simulation, doing it now, at the speeds and feeds that I want to run at, that I think will make a good finish. It gave me a cycle time of 28 minutes per pallet, and I'm like, are you kidding me? It should go fast. Like, look how fast that goes. Except the deeper into the run you go, the more linear length the tool takes, so it takes longer to get around every circle, basically. So it just gets slower and slower and slower around the outside. So I'm starting to believe the 28 minutes now. Now, hypothetically, I'm not going to do this, but I could do this hypothetically if I had more trust, more confidence, more experience on the machine. This is the kind of machine you could put all 25 blank pallets in there, put a fresh tool in, as long as you are confident that the tool is going to last doing all that work, whatever. You could write a quick program that runs the same piece of code for each 25 pallet. Robot changes it out, pallet 2, do it, pallet 3, pallet 4, pallet 5. I could go home, come back in the morning, 28-minute cycle time per pallet. I mean, that's a lot. 28 times 25 pallets divided by 60 is 11 hours, but that's what this machine does, is it just goes and goes and goes. So I mean, it's almost midnight now. I'm probably gonna cut it down right here. Maybe I'll sleep on it, whether I face down these pallets or not. I'm like I said before, I'm leaning towards no. The 5 or 6 pallets that I measured were all within a total range of 2/10. Total, like, in all areas that I checked on the pallets and between each other. That's pretty darn good. I don't know. Let me think about it. Sleep on it. Anyway, guys, yeah, I should really get going. And that'll do it for this video. I'll be back for the next few days. So, we'll dig in deeper. All right, guys. Thanks. Bye.